Okay. D has a similar feel to the last one, but here's one little thing you need to remember. If you take the absolute value of a perfect square, daggum, if you take the square root of a perfect square, it's absolute value. Oh man, I gave away the ending in the middle of the statement. Okay, so here we go. So on this one, then let's rewrite. So we've got the limit as x approaches 3 from the right. All right, I have another one of these, and it just doesn't look like it at first, but it is. So up top, I'm going to go ahead and factor out the 4. So I've got 4 times x minus 3. Okay. I'm going to show every step here. And so this is the denominator is the square root of x minus 3 squared. Okay. All right. Which, by definition, is the absolute value of x minus 3. It's not equal to x minus 3 because x minus 3 could be positive or negative, and this thing is always going to be created to be positive because of the squaring and then, of course, the square root. So let's rewrite. So I've got the limit as x approaches 3 from the right of 4 times x minus 3 over the absolute value of x minus 3. Okay. So, all right, now, and this is 1 or negative 1, depending on where you're at. If both of these are positive, it's 1. If that one's negative and that one's positive, then it's negative 1, of course. So, but I'm to the right. So this is going to be positive all the time. So this would cancel out and leave you with a positive 1. And then the only thing remaining is the 4. Now, hold on though. If I was approaching from the left, these two then would be opposite of one another, and that'd be negative 1. That would make that negative 4. Okay. All right. Hey, let's try the shortcut way on this one. Let's multiply, and you can do the other way if you want. It's up to you. Let's multiply by x times x plus 3. Oh yeah, on top and bottom. Remember, there's a couple of different ways to do it. There may even be another one, but these are the two that I'm very familiar with. Um, I like doing them this way, and this one's really good. Okay, so the result of this is the limit as x approaches 0. All right, and now the numerator is going to be, when I multiply this numerator by this left-hand side of the numerator here, you're left with the x plus 3. This is the one I messed up on in class the other day. I multiplied by the wrong thing. And then we multiply this fraction by this numerator here. X plus 3's cancel, and you leave you with an x. Good. And then I think we've got a problem. I think we've got a problem. Okay. Well, I'm going to continue, and then we'll fix our problem later because I do believe we have a problem here. I didn't try to do the direct substitution. That is undefined, of course, plus 1/3 over 0. That is a strange one. Okay. So, yeah. All right. I noticed that right here when these two x's aren't going to cancel out. Nothing's going to cancel out. So we've got a little bit of an issue, but let's make it work. Let's make it work. Let's keep going. Okay, so then my denominator is going to be x squared times x plus 3. So x squared, I think I said times, x squared times x plus 3. No, I was right the first time. All right. Okay. All right. Interesting. Okay, so, all right, well, we'll just keep going with this, even though I know it's a mess, but it's okay. So x approaches 0. We'll see if we'll look and see if there's another way to think about it. So my numerator is 2x plus 3, and my denominator is x cubed plus 3x, x cubed plus 3x, which I think I just want to leave it like this for right now. So here we go. So I'm going to leave it factored just for a moment so we can talk about it. Because that x squared is not going to do anything for us. I mean, it is, but that's the thing that we're going to try to make very, very small. Okay. All right. Now, all right. So we're approaching 0. So if I'm approaching 0 on this, of course, direct substitution is not going to work. We have an asymptote here, without a doubt. We have an asymptote, and now we need to know if it's going to positive infinity or negative infinity. All right. So what we're going to do is we're going to be approaching from both sides. So if I put a 0, if I were able to put something close to 0 in here, that would be 3. So that's a positive number on top. So we got a positive number on top, right? But on bottom, what's going to happen? Well, if I'm approaching from the right and I get very, very small, of course, this is going to create the infinity situation. Well, so would this. They both would. But if I'm approaching from the right, that's going to be like 3.001, right? And so if I do that, 3.0, no. So 0.0000, like 0.00001. All right, squaring that makes it small. But here's the thing, though. When I put it in here, I'm going to have a very small number plus 3. So I believe that thing is going to positive infinity, right? Yeah, because, all right, going to pause on E. Going to pause.